Download a 2 hours movie in 3.6 seconds. That's what 5G promises. But here's what the marketing doesn't tell you. Speed is only part of the story, and maybe not even the most important part. I'm Wesley, a radio frequency engineer working in this field for over 15 years. And here on RF 101 Explained, we break down radio frequency technology in ways that actually make sense. Today, we're diving into 5G. Not the hype, not the conspiracy theories, but the actual engineering that makes it different from everything that came before. And stick around because at the end, I'll show you how to check if you're actually getting 5G or just glorified 4G with a fancy icon. Let's start with the most fundamental difference. Where 5G leaves on the radio spectrum. 4G operates mostly between 700 MHz to 2.5 GHz frequency range. Think of these as normal radio waves. They travel far, penetrate buildings well, and that's why 4G coverage is pretty much everywhere. 5G uses 3 different bands. Low band, ranging from 600 MHz to 1 GHz. This is 5G's disguise as 4G. Slightly faster, but nothing revolutionary. Most nationwide 5G you see advertise it as 5G as well. Your phone shows 5G, but you won't notice much difference. Mid-band, ranging from 2.5 to 6 GHz. The sweet spot, 2 to 3 times faster than 4G, decent coverage, works indoors. This is what most cell phone operators use as their primary 5G. mmWave, ranging from 24 to 40 GHz. This is where the magic and the problems happen. mmWave frequencies can hit 10 to 20 gigabits per second. Insane speeds. But here's the catch. These waves are so small, they're blocked by everything. Your hand, a leaf, rain, a building. Forget about it. That's why you only see wave in stadiums, airports, and dense city blocks. It's like having a supercar that only works on a quarter-mile drag strip. So when carriers advertise 5G Ultra or 5G Plus, that's code for millimeter. Great in theory, rare in practice. Here's where 5G gets genuinely clever. Beamforming. 4G towers broadcast signals like a sprinkler. Radio waves spray in all directions. If you're the only person in range, great. But if 100 people are trying to connect, that signal gets divided 100 ways. 5G uses something called massive MIMO, multiple input, multiple output. Instead of one big antenna, 5G towers have arrays of 64, 128, sometimes 256 tiny antennas. These antennas work together to create focused beams aimed directly at your phone. It's like instead of a sprinkler, you get a precision water jet pointed right at you. But here's what's wild. The tower does this for every connected device simultaneously. Your beam, my beam, that guy's beam. All at the same time, all independent. This is why 5G can handle way more devices than 4G in the same area. It's not just about speed, it's about capacity. In a stadium with 50,000 people, 4G chokes. 5G? It creates 50,000 individual beams. Engineers call this spatial multiplexing. I call it black magic. Now let's talk about the feature almost nobody mentions, but might be 5G's biggest innovation: network slicing. Imagine this. You're streaming a movie, a surgeon 10 miles away is performing remote surgery using a robotic arm, and a self-driving car is making split-second decisions, all on the same cell tower. Which one needs the fastest response time? Obviously not your Netflix binge. The surgeon needs 0 lag. The car needs 1 millisecond latency. You can buffer. 4G treats all traffic the same. 5G can create virtual slices of the network. Separate dedicated lanes with different priorities. Slice 1. Ultra-reliable low latency for medical devices and autonomous vehicles slice. High bandwidth for streaming and downloads. Slice 3, massive IoT connectivity for sensors and smart devices. Each slice has its own guaranteed quality of service. It's like having 3 separate networks running on the same infrastructure. This is why 5G is being called the backbone of Industry 4.0. It's not about faster YouTube. It's about making mission-critical applications possible. Okay, so 5G sounds amazing. Why doesn't it feel revolutionary yet? 3 reasons. 1. Coverage is still patchy. Most 5G is low band, barely faster than 4G. mmWave is rare. Mid-band is rolling out but takes years to build. 2. Your apps don't need it yet. Instagram works fine on 4G, Netflix works fine on 4G. Until apps and services are built for 5G capabilities, you won't notice much. 3. Battery drain. 5G radios use more power. Your phone is constantly switching between 4G and 5G. Result? Your battery dies faster. But here's what is changing. Cloud gaming is becoming viable. Think Xbox or PlayStation, but streaming from the cloud with no console needed. AR and VR are getting real-time responsiveness. Low latency means no motion sickness. Smart cities are deploying thousands of sensors, traffic lights, air quality monitors, infrastructure sensors, all on 5G. The revolution isn't happening on your phone, it's happening in industries you don't see. All right, I promised you, I'd show you how to check if you're getting real 5G. On iPhone, go to Settings, then Cellular and Cellular Data Options, and Voice and Data. Look for 5G UC or 5G UW, ultra capacity / ultra wideband, equals midband or mmWave. Just 5G? That's likely low band equals not much better than 4G. On Android, it varies by phone, but generally is on Settings, the network and preferred network type. Want to test your actual speed? Use speed test on fast.com. Real 5G midband, 100 to 400 megabits per second download. 5G mmWave, 500 to 2000 megabits per second download. Low band 5G, 30 to 75 megabits per second. Basically 4G speeds. If you're getting 30 to 50 megabits per second and it says 5G, you're on low band. Your carrier is technically correct, but it's marketing more than technology. So is 5G revolutionary? Yes, just not in the way you think. It's not about downloading movies 10 seconds faster. It's about creating the infrastructure for technologies we're just starting to build. Autonomous vehicles need 1 millisecond latency. Remote surgery needs guaranteed reliability. Smart cities need to connect millions of devices. 5G makes all of that possible. Your phone, it'll get faster over the next few years as coverage improves. But the real 5G revolution is happening in factories, hospitals, and infrastructure, places you'll never see. If you learned something today, hit that subscribe button and like this video. I break down RF concepts every week, from Wi-Fi mysteries to how radar actually works. Next video, I'm diving into why your Wi-Fi is slower upstairs than downstairs. The physics is wild. Drop a comment. What RF topic should I cover next? Antenna design, Bluetooth, how radio telescopes work. Thanks for watching RF 101. I'm Wesley, and I'll see you in the next one.